Hello? Oh, okay. I will start. Oh, Hello? Yeah, good afternoon, everyone. This is Ambuj Kumar Jha from Indian Institute of Tropical Meteorology, Pune. I am going to present on atmospheric and orographic drivers of extreme rainfall episode over the Western Ghats in July 2026. So, we know that the Western Ghats frequently experience intense rainfall during the Indian summer monsoon season, mainly because of the interaction between moist monsoon winds and the complex topography of the region. During the first week of July 2026, an extreme rainfall episode occurred over the Western Ghats. So, in this talk, I am going to present an analysis of that extreme rainfall event which occurred over the region. And the objective of this work is to understand the large scale atmospheric conditions and the local orographic factors that contributed to this event. In particular, I will show satellite observations along with reanalysis data and high resolution X-band radar observations of Mahabaleshwar for this event. Now, this slide here, it shows the time series of daily all India rainfall for the ongoing summer monsoon season of 2026. So we know that the monsoon season of this year began with a delayed onset, and it was relatively sluggish during June. And at that time, there were concerns that there is a possible influence of developing Super El Nino, which can suppress monsoon activity. However, the monsoon gained strength abruptly during the last week of June, and there was a rapid revival of monsoon in the in the last week of June to first week of July, particularly in this period, as shown by this red arrow, and there was a rapid revival of monsoon activity across the country. And Mumbai was in news as it experienced heavy rainfall, exceptionally heavy rainfall, and and in fact, most stations in Mumbai they recorded more than 80% of July rainfall in first 4 or 5 days of July itself. So now. Uh, uh, So this slide shows the spatial distribution of mean rainfall during 3 to 8 July, during 26 June to 10 July actually. That heavy rainfall period which was marked by red arrow. And it is based on IMERGE late run product. Because the final run research quality product is not available till now. So I've used the late run product, and you can see here this box, it shows the region of high rainfall, while this vertical line it represents the mean longitude of the Western Ghats between 16 and 21 degree north. And a prominent maximum can be noted in the offshore region of the Arabian Sea, while secondary rainfall band is seen concentrated along the Western Ghats. And these two stars indicate two observational sites of IITM. That is, this star is Mahabaleshwar, which is in the windward side, and this is Pune, which is in the leeward side. And we know that Mahabaleshwar receives a very heavy rainfall as it is located on the windward side, and Pune, which is on the leeward side of the Western Ghats, rainfall is considerably lower because of the rain shadow effect. And so the time series of daily rainfall for these two stations are plotted here. And you can see that substantial rainfall is received at both sides during 3 to 8 July period. And starting from 3 until 8, you can see that the rainfall received is substantial. And at Mahabaleshwar, actually, extreme rainfall was reported during 5, 6, and 7 July. As per IMD definition of if the daily rainfall exceeds 204 mm per day, then it is considered extreme rainfall as per IMD definition. So as per this definition, Mahabaleshwar reported extreme rainfall on these days. So therefore, I will consider these 3 days, uh, that is 5, 6, and 7 July as extreme rainfall days in this analysis. Now, this is the so we constructed a homolar diagram of 16 to 21 degree north averaged rainfall, and so this figure basically shows how the rainfall evolved from west to east across the Arabian Sea to the Western Ghats. And after 3 July, that is this line, you can see that rainfall, there is an intensification of rainfall, and a prominent region of rainfall maximum is developing over the offshore Arabian Sea on 5th July. And afterwards, the region of rainfall maximum is gradually shifting eastwards over the Western Ghats till July 8. And afterwards, you can see that after 8th July, surprisingly, there is a drastic decrease in rainfall, and the entire band of rainfall disappears. Same pattern was seen earlier in case of the time series of daily rainfall plots, Mahabaleshwar and Pune. After 8th July, the rainfall drastically reduced to minimum values. So, so basically here I want to highlight that there are two regions of heavy rainfall observed during this period, 26 June to 10 July. One in the offshore region and other over the Western Ghats. Of course, the offshore region is having a very intense rainfall compared to the Western Ghats. Yeah, and this slide basically shows the extreme rainfall period, that is 5 to 7 July. So, which I showed in earlier slide. Now, I took mean OLR from INSAT 3DR during 3 to 8 July, which is this period when heavy rainfall received over Arabian Sea and the Western Ghats. So I found that a prominent low OLR region over the offshore Arabian Sea and the coastal region, and which is indicative of persistent deep convective clouds. On the other hand, the OLR over the Western Ghats shows relatively higher values compared to the Arabian Sea, and which indicate that relatively shallower clouds are dominant during the extreme rainfall episode. And this feature can be seen more clearly in this homolar diagram of daily OLR data averaged over the same latitude region, 16 to 21 degree north. And here you can see, so this vertical line actually demarcates the offshore region and the Western Ghats. So you can see left to this line, which is the offshore region. Here very low OLR values are observed, while right to this region, in the Western Ghats, high OLR values are observed. So which indicate that the offshore region is dominated by deep clouds, while Western Ghats is dominated by relatively shallower clouds, even during extreme rainfall event. Now, I looked into the spatial pattern of 850 hectopascal winds at 12 UTC for each day, starting from 3rd to 8 July. And these shadings of color bar, they represent wind speed. So IMD reported the formation of a low pressure area over northwest Bay of Bengal in this region around 3rd July, which subsequently intensified to depression on 5th July. And the movement of this system was in the northwest direction, and it favored strong surge in this westerly winds. As you can see here, there is a strong surge in westerlies over the Arabian Sea, particularly on 5 and 6 July, which caused large moisture transport towards the Western Ghats. And also note that there is a flow of northwesterly and northerly winds from the desert regions into this region. So which I will discuss later. In later slide, I will discuss that part. Yeah. So in this slide, we examined the mean sea level pressure contours to understand the offshore trough formation and movement. And we can see that the offshore trough is not so prominent on 3rd and 4th July, while in 5th July, the offshore trough is well formed, and afterwards you can see on the for the extreme rainfall days, that is 5th, 6th, and 7th, the offshore trough is well formed, and the contours are closely spaced, and the troughs are also deep, and you can see that there is a well marked deepening of trough around Mumbai, particularly on 5th July, 6th and 7th. So around this region, so the troughs are becoming very deep. And so sometimes when these troughs become very deep, small scale cyclonic vortices develop, which further enhance the rainfall activity. So which we found in this case also. Uh, so here for a uh, particular on 6th July 00 UTC, so we observed that there are in this trough, so there are embedded vortices. Yeah, so in fact, we can see that the offshore trough is shifted towards the Western Ghats and apparently not in the offshore region. To examine further, we overlaid relative vorticity on the offshore trough. So these shadings are relative vorticity values and at 850 hectopascal level. And we found strong signatures of positive relative vorticity during 5th to 7th. So you can see here trough-like shape of relative vorticity is appearing on the on the extreme rainfall days of 5th to 7th July. So now we looked into the pressure longitude cross sections of specific humidity with wind bars across 19° north, and we observed that a deep layer of moisture and westerlies, if you can see closely, so the moisture layer and the westerlies are deep on 3rd July, while on going forward on 4th July and later days, so there is an intrusion of northwesterlies and westerlies, gradual intrusion of dry air by north westerlies and westerlies at middle and upper tropospheric levels. And you can see that the atmosphere is becoming drier in subsequently. So earlier the moisture layer was deep, and in later days, so because of the dry air transport to middle and upper tropospheric levels by these northerlies, and there is that middle and upper tropospheric humidity is decreasing, so which is cutting off the development of deep clouds. And so what we understood that the key mechanism is that under the influence of westward or northwestward progression of Bay of Bengal LPS, the monsoon westerlies strengthened, and it caused intensification of offshore trough and the small scale vortices. And as the LPS weakened and dissipated, the northwest dry air intrusion became dominant, and it acted as a terminating mechanism, which then cut off the development of deep clouds and heavy rainfall, and then the rainfall band disappeared and subsided. So now we have looked the large scale atmospheric conditions. Now we looked into the spatiotemporal evolution of extreme rainfall at local scale using radar data. So IITM has installed an X-band weather radar at Mahabaleshwar in the Western Ghats, and this is the X-band radar SSPA based X-band radar, which is installed on a 17-meter tower. You can see in this figure, and this is the topography map of the Western Ghats of the radar domain. And this right figure here, it shows the beam blockage map of radar. So in this sector, there is a complete beam blockage, and therefore the radar is not able to see at lower levels in this particular sector. So for rainfall estimation, so we are not getting data for this sector. So now we looked into radar derived daily accumulated rainfall amount, which we got at 1 kilometer resolution. So interestingly, most of the rainfall during this period, as you can see, is concentrated in a small region, and most of the high rainfall occurs over elevated terrain, which as you can see here, most of the heavy rainfall is concentrated in this particular region over the elevated terrain. So which suggests that there is a strong orographic lifting and is acting as a dominant mechanism for this heavy rainfall accumulations in this region. And I'm not shown here, but actually most of the precipitating clouds which uh, produced this heavy rainfall accumulations, they propagated mostly from northwest and west. And as they hit the orographic barrier, there was strong orographic lifting, and which produced heavy rainfall accumulations in this particular region. I was not expecting this, but I am seeing that on 3rd July, actually, we received higher accumulation, and the spatial extent of the rainfall, heavy rainfall areas is larger compared to other days. Even though we received substantial rainfall over Mahabaleshwar and other areas as well, but the extreme rainfall episode of 3rd July was seemingly more intense. So we also looked into radar rainfall frequency, and we found that for 3rd, 4th, and 5th July, particularly 4th July, the rainfall frequency is very high over the in this region. But if you see the rainfall amount for the 4th July is not very high. The rainfall amount is in fact the lowest compared to all other days, and while the rainfall frequency is the highest. So why it is coming out like that? So it is explained by the radar derived daily mean rain rate, which shows that even though the frequency is higher, but the mean rain rate over this region is lower compared to other days. And on 3rd July, the rainfall frequency as well as the rain rate, means the intensity of convection is also high. So which is leading to very good amount of rainfall, substantial rainfall accumulation in this region. Now we wanted to examine the nature of clouds. What type of clouds actually uh, led to this kind of heavy rainfall accumulations. We looked into the vertical profiles of precipitating clouds. So by looking into the vertical profiles of radar reflectivity for the over Mahabaleshwar for the study period, that is from 3rd to 8th July. Um, and we can see that these were the heavy rainfall, these were the extreme rainfall days, that is 5th, 6th, and 7th, and 6th was the highest. So we can see before 6th, in most of the occasions, you can see that there is an enhanced region of high reflectivity at this layer around 4 kilometer. So which is the melting layer, and this shows that which is actually known as the radar bright band, and it is indicative of stratiform kind of precipitation. So it shows that the stratiform rainfall was occurring frequently on these days, while after this 6th July, the convective rain was dominant, and even the cloud tops are much higher. On 6th July, the cloud tops are in fact highest in case of 6th July. So which indicates that deep convection was dominant over Mahabaleshwar. And that's why. But one interesting feature here to note is that even though it is clouds are not very deep, and actually most of the clouds are yeah, of the are can be considered as mid-level or cumulus congestus type of clouds. So which so it is over the Western Ghats. So it is the rainfall frequency that is mattering the most for the production of the substantial rainfall accumulations. Yeah. So with this, I would like to thank you for listening to my talk. Yeah. Thank you very much. If you have any questions, please let me know. I will be happy to answer.
Yeah.
Yeah.
Huh? Yeah. Is the circulation data you showed, is it IMD or NCMWF? Which one is used?
Which sir? What circulation data?
Yeah, the circulation data. Yeah. Yeah, that.
You mean to say this one?
Yeah, that one.
No,
Yeah.
this is ERA 5.
Okay.
Yeah.
And how good was the forecast for this period? The
Yeah,
forecast of
it
IMD.
was yeah, it was good. It was good. So it was well predicted, and red alert was issued even 2 to 3 days uh, in advance, and most of the preventive measures were taken well before the this kind of rainfall. So the
Okay.
forecast for this episode was good.
Yeah. Anybody else here?
Yeah, hello. Nice presentation.
Yeah, thank you,
So,
sir.
yeah, is there an inconsistency between the accumulated rainfall and you know, the rainfall frequency in the radar data?
Yeah, that is what we observed here. So because rainfall amount is explained, rainfall amount depends on two factors. One is rainfall frequency, other is rain rate. So when the rainfall frequency is not able to explain the rain rate, so it implies that rain rate should have been higher. So that's how. But one or the other factor will decide the rainfall accumulation, overall rainfall accumulation. So it is able to explain. So far I'm not seeing any inconsistency in that term.
Okay. So the other question I have is a slightly more general question, because there was a similar episode over Kerala during the first week of August, when there was a 30 centimeter rainfall in a day, only in a few pockets. You have any comments on that?
No, I haven't looked into that event. Uh, so. So I've not analyzed that event. I don't know means what synoptic conditions were prevalent. Even for this data, even for this event, many data sets I have used. So this is still in some post-processing stage. So I have taken the data and I analyzed and showing presenting here.
Thank you.
Yeah.
Huh? Online? Yeah. Can you see the chat box? There is a question about the offshore trough. That slide.
Okay.
Yeah, I want the slide again.
Can you explain the slide again where you, yeah, sure, I will. share the screen. Yeah. What I meant to say that this offshore trough got well formed, particularly on the extreme rainfall days of 5th, 6th, and 7th July. As you can see here, on 3rd and 4th, the offshore trough is not looking well developed, while on 5th, 6th, and 7th. So the contours are closely spaced, and the trough is also got deepened. And later on 8th July, you can see the over this Mumbai and Western Ghats region, the deepening of the trough has reduced. So when we looked more into the offshore trough structure on 6th July 00 UTC, we found that there are embedded small scale vortices. So which which may have led to intensification of development of clouds and intensification of rainfall in this region around 20° north. So I think the question asked me to explain the offshore trough. I think that was the question. So if there is any other clarification you want, please let me know, or you mail me regarding any questions you may have in from the slides. So I will be happy to answer.
Okay.
Yeah.
Thank you. Yeah. So if there are no other questions, we'll ask Ritesh.
Okay. Thank you.
Good evening, everyone. So today I'm going to talk about the interaction between the low frequency ISOs and the seasonal mean, how they interact with each other, how they affect each other formation or the values. So before going to that, just to give a brief idea. So JJS rainfall constitute of about 90% of the annual rainfall. And within a season, there has been a variability which is called as intraseasonal variability. And within the intraseasonal variability, two prominent variability comes out to be is low frequency ISOs, which has a typical time period of 20 to 60 days. Some papers quote it as 30 to 60 days. And we'll see the structure also of this low frequency ISOs, which I'm going to talk about in more detail. And then second prominent variability comes within a season is high frequency ISOs, which is a 10 to 20 days mode, which has a westward movement from the Bay of Bengal and has a time period of this. So it has been found that the low frequency ISO intensity is been negatively correlated with the seasonal mean monsoon rainfall, all India summer monsoon. Why is that? Why the northward propagation component does not lead to the actual rainfall or leads to the drier seasonal mean? So I'm going to be discuss this paper, which talks about the interaction between summer mean monsoon and the intraseasonal oscillation. By intraseasonal here is 30 to 60 day mode, not with the HFISO. And in this paper, they try to understand what seasonal component affects the intraseasonal part and what is the feedback of intraseasonal to the seasonal feedback. It's a 2008 paper by Key et al. In GRL. So I'll be giving much of the result from this paper, and to support some of the result, I'll be taking from the other, even from my analysis too. So here is the plot which shows that LFISO, or the intraseasonal oscillation, or 30 to 60 day mode, has a negative correlation and over this region, which is central India, eastern India, and the northern Bay of Bengal, which has this correlation comes out to be the significant, statistically significant by 90 at the 95% level. And if we see the all India anomaly of all India summer monsoon and the 30 to 60 day OLR standard deviation anomaly, which is to find the correlation between these two, is come out to be the minus 0.6. So here, they are saying that the LFISO intensity in this paper, this LFISO intensity, or the 30 to 60 day ISO mode intensity, is basically this bar, which is kind of they calculated by calculating the standard deviation anomaly. This is old paper, so the method is little different here. Just to keep in mind that this is the intensity of the LFISO. This is the all India summer monsoon anomaly, and it's coming out to be out of phase relationship with each other. Now, to understand that, they have looked at the rainfall, or the OLR in this case, at eastern equatorial Indian Ocean with the actual rainfall over the monsoon core region. And it's come out to be minus 0.4, which means that whenever there is a monsoon occurs over the monsoon core region or the central India, there is a suppression, or the suppression of monsoon over the eastern equatorial ocean. Why I'm talking about the eastern equatorial ocean? Because of this reason. So this is the typical structure of LFISO, which there is a eastern. If we look at here, phase 8, this focus on this blue part only. This is which starts over the western equatorial Indian Ocean, moves to the eastward, reaches at the Indonesian coast. From here, the convection starts northward. Now, earlier what I have said, if the monsoon occurs over this region, there is a negative correlation over there with this region, which means whenever the monsoon occurs over the northern, there is a suppression which does not allow the formation of monsoon over here, which is the initial part of the LFISO intensity. That's why for a wet monsoon season or the flood years, the ISO intensity come out to be the lower or weak ISO years. They have also checked by using the wave number frequency analysis. So to get the eastward part, they have looked at 40 degree east to 180 degree east, plus minus 5 degree north. So this is for wet monsoon years. This is for the dry monsoon years. And we can clearly see for the frequency is 30. This is the magnitude. This is the magnitude in the wet monsoon years. We can clearly see the eastward movement is stronger during the dry years. This is same wet dry, this is to check whether there is a northward propagation or not. For that, they have taken 10 degrees south to 40 degree north and 85 to 90 degree east. And we can clearly see during the drought years, this northward propagation is also stronger. In order to support that, I have looked at this moisture budget part also. So this is a typical equation for the moisture budget. This is the horizontal advection term, and this is the vertical advection term. And then I decompose into mean and perturbation of these two terms, and I plotted the mean terms. So this is for the flood years or the wet monsoon years. This is for the drought years. If you look at the monsoon core region, it is coming out to be green, which is supporting the precipitation. This is the equation. This negative, this whole term, if it's coming out to be green, the mean term, it's going to support the precipitation. For the drought years, it's coming out to be negative. This is the mean structure I'm talking about. So in the mean scale, it's going to support the rainfall over the monsoon core region. This is horizontal advection term, mean horizontal advection. When we look at the seasonal daily, this is the daily anomaly plus seasonally averaged of daily anomaly. So any day is kind of, any mean term, any day of the mean term is kind of, it includes the anomaly plus the seasonal component of that year. So the no, so the mean term I calculated in a way. So first I calculated the anomaly, daily climatology. Then I calculated the daily anomaly. I averaged the daily anomaly and added to the daily climatology. So for any day, the bar term will have the daily climatology component along with the seasonal component of the daily anomaly. That's the mean term. Sorry? Yes. No, so if we averaged over all the years, all the climatological years, then it's come to, out to be, this term will be 0. When we kind of separate out the different kinds of years, flood, drought, or strong ISO, weak ISO years, then it will have some value. Yeah. Yeah. And this is for the omega bar, del Q bar by del bar, or the mean vertical term. Here we clearly see for the flood years, this is coming out to be the positive, and over this belt, equatorial is coming out to be negative, which again supports the result from the 2008, which tells this seasonal cycle suppress the formation of LF-ISO mode, which starts from the Indonesian coast. For the drought years, it's positive over this region, negative over this region. Now, till now, we have discussed how the seasonal cycle suppress or enhance the formation of LF-ISO. Now we are looking at the feedback part. When the ISO movement happens, how they affect the seasonal part. So first they want to calculate or see the linear effect. Is there any linear effect of this or not? The second, they looked at the non-linear effect. To get a linear effect, what they have done, they just accumulated the anomaly part here of OLR from 1st June to 30th September. Just add all the values, get one values for a season, and then compare it with the seasonal anomaly of OLR. So they just added all the filtered value from 1st June to 30th September of OLR. They added all the values over this region, average over this region, and then they have taken the seasonal average, seasonal anomaly of that region, and they compared. They compared and found to be only the correlation to be minus 0.04, which is almost 0. So they basically trying to say there is no linear effect of ISO on the seasonal mean. To get the non-linear part, they have chosen one of the indicator, which is zonal mean, indicator of the monsoon. If the monsoon is strong, this wind will be stronger. If monsoon is weak, the westerly will be weaker. So what they have done, they have taken the 850 hectopascal wind. They calculated this tendency. U bar is the zonal mean, seasonal mean of zonal wind by time. And this is the moment transport element, which is, this is due to zonal, this is due to meridional, this is due to zonal. And it is directly proportional to that term. And in order to calculate, they took the weak ISO terms minus strong ISO years. Weak minus strong ISO years. This term comes out to be plus 4.1. The acceleration comes out to be this 4.1 meter per second, which in turn supports that weak minus strong ISO years, or in other words, flood minus drought years, this intensity will be stronger. And they have taken June and July just to when the monsoon in a developmental stage, that's when the tendency comes out to be much stronger for the weak ISO years or the flood years. But the non-linear term comes out to be minus 12.9 meter per second, which tells that this term is going to, so this is weak minus strong. So for strong ISO years, this value comes out to be like plus 20. For weak, it comes out to be plus, let's say 6. That's why the summation comes out to be plus minus 13. So this term is actually weakening this monsoonal or the zonal tendency. So ISO through the non-eddy momentum transport is eventually going to reduce or weaken this momentum or this tendency, this zonal tendency. So that's why the negative correlation or the feedback of ISO which comes to the seasonal mean. So first we have discussed about how the seasonal mean or the seasonal monsoon convection, which happens over the central India, suppress the formation of ISO. Once the ISO comes, how this in turn weakens the seasonal monsoon flow or the westerly over the India. So in this way, yeah. So this is the small presentation. Thank you. Daily era file. Oh, so the maximum, it's within 0.5 mm per day. 0.5 mm per day. It's within that region.
So if it's 30 people below normal, then so we'll see whether